Hi guys, this is a review for the chapter test on ratios and rates with fractions. So the first topic that we did in this chapter was unit rate with fractions. When we initially did these questions, we did them as unit rate questions, and when we find unit rate, we just divide. When we did the review for this in class, I went over them as proportion questions because I think that's a little bit easier. Because for the other questions in the chapter, you're going to be using proportions, so this way you can be consistent and just use proportions throughout. So the first question here says, during a bake sale, 2 dozen cookies were sold in 1/3 of an hour. What's the unit rate for dozens of cookies sold per hour? So I'm just going to set up a proportion, and I'm going to start with the ratio that they give me and write that as a fraction. So I'll have 2 dozen in 1/3 of an hour. And then I'm going to line up my units. So I'll have dozens on the top and hours on the bottom. Now I'm looking for that other piece of information that I can fill in. So it says, what is the unit rate for dozens of cookies sold per hour? Per hour means for 1 hour. So I'm going to fill in a 1 for the hours and then an x for the dozens. And then I'm just going to cross multiply. So 1/3 times x would give me 1/3 x, and 2 times 1 would give me 2. So now I have the one-step equation, 1/3 x equals 2. This is multiplication. So the opposite of that is division. So to solve this, I'm going to divide both sides of my equation by 1/3. The 1/3s are going to cancel out because 1/3 divided by 1/3 is just 1. So I just have x equals, and then I just take my calculator and do 2 divided by 1/3, and that gives me 6. Alright, so this question is very similar. So it says a recipe for salad dressing calls for 1/4 cup of vinegar to 2/3 of a cup of oil. How many cups of oil are needed for each cup of vinegar? So I can do this as a proportion. I can also do unit rate, but I'll set it up here as a proportion. So I'm going to take what they give me and write that as a fraction. So 1/4 cup, and I'll label that V for vinegar, for every 2/3 of a cup of oil. And then I'll line up my units. So vinegar on the top, oil on the bottom. And then it says how many cups of oil are needed for each cup of vinegar. So for 1 cup of vinegar. So I'll put a 1 for the vinegar and an x for the oil. And now we're just going to cross multiply again. So 1/4 times x is 1/4 x, and 2/3 times 1 is 2/3. And now again, we're going to solve this by just dividing both sides by 1/4. So those are going to cancel out. And then you're going to take your calculator and do 2/3 divided by 1/4, and that gives us 2 2/3, which is choice C. Alright, the next question here is just solving a proportion. Alright, so here we're just cross multiplying. So I have 2 times x is 2x, and 3 times 12 is 36. Right, and then we're just going to solve this for x, so we'll divide both sides by 2, and 36 divided by 2 is 18, so we get x equals 18. The next question here, same kind of thing, we're also going to use a proportion. So it says, how many cubic yards is 144 cubic feet? And it tells us here that 1 cubic yard is 27 cubic feet. Alright, so step 1 says we're going to write this unit conversion as a fraction. So 1 yard is 27 feet. And then we're going to line up our units. So I'll have yards on the top and feet on the bottom. Now step 3, we're going to find the other piece of information. So it says 144 cubic feet. Because that's feet, I'm going to fill that in on the bottom. And then we'll put an x for the yards. That's what we're trying to find. And now again, it's just cross multiplication. So 27 times x is 27x, and 144 times 1 is 144. And then we're going to divide both sides by 27. So our 27s will cancel out, leaving x. And then 144 divided by 27, you're going to get 5.3 repeating, or if you prefer fractions, that's 5 1/3. Now, these next two questions here are similar to these, but with one extra step. Right? So this one says, Diane can type 1,350 words in half an hour. What is Diane's average typing rate in words per minute? So the issue here is that it's telling us words and hours, but it's asking us for the rate in words per minute. So our units aren't matching up here. So because we want words per minute, my first step is going to be to change this half hour into minutes. So I know that a half an hour is 30 minutes. So I'm going to change this half hour to 30 minutes. And now I can go ahead and set up a proportion. So it's 1,350 words in 30 minutes. So we're going to line up words with words, minutes with minutes. What is Diane's average typing rate in words per minute? So for 1 minute. So put a 1 for minutes and an X for the words. And then again, just cross multiplying. So 30 times X is 30X. 1,350 times 1 is 1,350. And then we're dividing both sides by 30. So our 30s are going to cancel out. And 1,350 divided by 30 is 45. Alright, same kind of thing down at the bottom, and it says Ms. Hernandez grades 3/20ths of the tests in 15 minutes. If she works at the same rate, what portion of the test will she grade in 1 hour? So again, it's talking about tests and minutes, but then it's asking us about tests and hours. So we need to do some kind of conversion here. So one option we have is to convert 15 minutes into hours. The other option is to convert 1 hour into minutes, and that one is a lot of times easier for people. So if we know that 1 hour is 60 minutes, then we can go ahead and set up our proportion. So we'll say 3/20ths of the test in 15 minutes. So we're going to line up tests with tests, minutes with minutes. What portion of the test, so that's X, in 1 hour, which we said is 60 minutes. And now we're going to cross multiply again. So 15 times X is 15X. If you do 3/20ths times 60, you'll get 9. And then we're going to divide both sides by 15. So our 15s are going to cancel. And if you divide 9 divided by 15, you're going to get 0.6. If you prefer a fraction, that's the same as 3/5. The next thing we did was look at a table of values and find the unit rate, and then answer some other questions about that. So it says the table below shows the relationship between the number of eggs and the number of cups of sugar required for a recipe. And the first thing we want to do is find the constant of proportionality, or the unit rate. So in order to do that, we divide y divided by x. So here the sugar is y and the eggs are x. The only full point that we have on the table is this last one. So that's the one we're going to divide. So we'll divide 15/4 divided by 6. So you're just going to type that into your calculator and divide it, and that's going to come out to 5/8. So our unit rate here, or our constant of proportionality, is going to be 5/8. So now the second part of the question asks you to write an equation. So your equation is y equals kx, where k is whatever your unit rate is. And we just found that in part A, it was 5/8. So our equation is going to be y equals 5/8x. Now for the next two parts of the question, you can use that equation, or you can use the table. All right, so I'll use the equation. So it says, how many cups of sugar would you need if you used 8 eggs?
Did somebody already clean here?
Yeah,
Oh.
I think.
Okay.
Yeah.
They did the wrong room, it's mine, so. Thanks.
All right, so I'm going to write down my equation. Y equals 5/8x. Now it says, how many cups of sugar would you need if you used 8 eggs? So if I look at my table, eggs was x, so I'm going to put 8 where the x is. So I'm going to have 5/8 times 8. And if you do the calculator, you're going to get 5. All right, then the last question says, how many eggs would you need if you used 10 cups of sugar? So again, if you use your equation, y equals 5/8x, the sugar is y. So I'm going to put 10 for y. And now to solve this equation for x, we need to divide both sides by 5/8. So our 5/8 are going to cancel out, and I'm just going to take my calculator and do 10 divided by 5/8. And that's going to come out to 16. All right, the next thing we talked about was finding missing dimensions on scale drawings. So a scale is the ratio that compares the length in a drawing or model to the corresponding length in the actual object. So here's an example of a scale, 1 inch to 12 feet. Well, what does that mean? Well, it means 1 inch on the model is 12 feet in real life. All right, and what you're going to use that scale for is to find your missing dimension. So the way we're going to do that is figure out what the scale is, write it as a fraction, and then set up a proportion by lining up your units. Okay, so the example says a scale drawing of Valerie's garden uses a scale of 2 inches equal 5 feet. If the garden's width on the scale drawing measures 3 inches, what is the actual width in feet of Valerie's garden? So step 1, identify the scale, and then write that as a fraction. So 2 inches equals 5 feet, and now I'm going to line up inches with inches and feet with feet. All right, if I find my other piece of information, it's 3 inches, so that's going to go on the top because that's where the inches are. And then we're going to cross multiply. So 2 times x is 2x, 5 times 3 is 15, and then to get x, we're going to divide both sides by 2, and x is going to be 7.5 feet. All right, now here this says continued from the last example. We need a little bit of information from the last example, so I'll just write that here so we don't have to flip. So we have the actual garden, and then we have the drawing. And in the drawing, the width is 3 inches, and we figured out that the actual width is 7.5 feet. It didn't say in there what the length is, so we'll just make up a length here so we can do the next part of the question. So we'll say the length of the drawing was 5 inches, and if we were to set up a proportion and figure that out, the actual length would be 12.5 feet. So these two questions are talking about the area of the garden. And since the garden was a rectangle, we need to use the formula for area of a rectangle. So that's A equals LW, area equals length times width. So if we're talking about the actual garden here, then I want to use 12.5 for the length and 7.5 for the width. So I'm going to have 12.5 times 7.5, and if you multiply those, you should get 93.75 square feet. Now the next part of the question says, what's the area of the scale drawing? It's the same formula, area equals length times width, but this time our length and width are going to be from the scale drawing. So I'm going to plug in 5 inches for the length and 3 for the width, and 5 times 3 equals 15. So our area of the drawing would be 15 square inches. All right, the last thing we talked about in this chapter was similar figures. So right here it says, observe the two figures below. How were the original dimensions changed to obtain the new dimensions? All it's asking is, how do I get from here to here? What do I need to do to 4 to get to 20? Well, 4 times 5 is 20. So how were the dimensions changed? I'm going to say they were multiplied by 5. Okay, so again, I'm just looking at how did this change to get from the first one to the second one. Last question here says, which triangle below is similar to triangle DEF? So when we talked about similar figures, we said two figures are similar if their corresponding sides are proportional. So what I'm going to do is match up my corresponding sides and see if it's proportional. So if I take this side in the original triangle, that would correspond or match up to this side in this triangle. So I'm going to say 6 goes with 8. And I want to know, is that equal to the ratio of the other sides? So the 15 would correspond to the 20. So I would match those up. There's a bunch of different ways that you can see if this is a true proportion. One way is cross multiply and see if you get the same thing. So 6 times 20 is 120. 8 times 15 is also 120. So this is a similar triangle. That is a true proportion. If I tried that out with these ones, it wouldn't. So I would have